All right, what's up, Algebra 2 fam? Here we go. We're doing our very first assignment. Let's fly right through it. So solve each equation. I'm going to go through this kind of at a slower pace. So if you don't need help on these first couple of questions, feel free to fast forward. 4n is equal to negative 44. We're going to go ahead and divide both sides by 4. The reason why is because that 4 is being multiplied by n. We're trying to undo that multiplication. So therefore, n is equal to negative 11. Feel free to use a calculator when appropriate. For number 2, this one should be nice and easy. We're going to start by subtracting 11 on both sides. We're going to get n is equal to 15. That one was super quick. After that, continuing on to number 3, again, nice and easy. We are dividing by negative 4. Please be careful. I've walked around the room, quite a few students put the incorrect answer. They said x is equal to 19. It is not. It is negative 19. When you divide by a negative, the negative sticks around. It's not like some other questions where it might not. Question number 4. This is the first problem where some students do not know what's happening on it. I do think the easiest way to do it is with the quote-unquote switcheroo. So I can take this. I'm going to do this problem twice, by the way. So I'm going to do it another time. I'm going to copy it just so we have another version of it. So over here, the switcheroo does make this question the fastest. We're going to take that negative n here. And we're going to switch spots with this positive 11. So that means that this negative becomes a positive n. And that 11 becomes a negative 11. And therefore, n is equal to negative 5. I think that's my favorite way of solving this question, is just going and doing that little switch. However, for this problem over here on the right-hand side, instead, a different student might instead say, you know what, I know the best move is just to subtract 6 on both sides, and you get 5 is equal to negative n. After this, we do want to remember the big rule of thumb, and the big rule of thumb is you're allowed to multiply all numbers and terms by a negative. If you do that, you get the same exact equation. So it's like this: 5 becomes a negative 5, and this negative n becomes a positive n. Last but not least, as an additional way of doing this question right here, you're at this step, is remembering that a negative n is the same thing as a negative 1n, and then we can just divide both sides by negative 1. And that'll give us that negative 5 for the n. Continuing on to question number 5. So in question number 5 here, I do think the kind of standard approach is going to be nice and neat. You can also do the switcheroo if it's making you happy, but the standard approach is probably going to be just fine, and there's nothing wrong with kind of showing that standard approach to it. So we got negative 32 here is equal to negative 8x, and then dividing both sides by negative 8 is going to give us 4 is equal to x. For question number 6, we have to start by going ahead and adding 3 to both sides. Again, a very standard approach. And then dividing both sides by 2. Number 7, another question that can be a little bit tricky in the end. Actually, sorry, number 8 is the tricky one. Number 7 should be nice and easy. We're just adding like terms to start. So we're going to do 7n plus 8n is going to be 15n. If you're wondering what happened there, we just literally combined the 7 and the 8 together to get the 15. And now we're dividing both sides by 15. And yet 1 is equal to n. Nice. Number 8, 0 equals negative 8 minus 7n. So first we do the same thing we did in the problem over there on the left, is we add like terms, and we get negative 15n. Some students get confused here, don't know what to do, because when they divide by negative 15, they think there's something wrong, but there isn't. You're always allowed to divide by negative 15 or something like it if you want. 0 over any other number is always just 0, with the only exception of 0 over 0. 0 over 0 is called indeterminate. We'll worry about that at a later date. All right, so number 9. There are 2 correct ways to do number 9. I'm going to do both of them right now. So the first thing I have to do is copy this problem for those who would like to see it both ways. The way I like doing this question is the fast way, and it's realizing that this is 7 times something, which is 84. So we can start by dividing both sides by 7. Starting by dividing both sides by 7, we get k plus 8 equals, and what is that, 12? Yeah. So you got 12, and then subtracting 8 on both sides. You get k is equal to 4. That's one way of doing the problem. However, a lot of students see these parentheses and their instinct is just to distribute. There's also nothing wrong with that. So 7k plus 56 is equal to 84. And then you can subtract 56 on both sides, and you get 7k is equal to, oh my gosh, what's it going to be? 34 minus 6, 28. And then divide both sides by 7. You get k is equal to 4. Either way, you get the same exact answer. Number 10, same exact idea. However, I'm not going to show this extra way. You are allowed to distribute if you want, but the faster way, again, is just to divide by that number in front. So in this case, we're also dividing by 7. When you divide by 7 here, I believe this one is going to be 16 with a negative. And then add 8 to both sides. And you get negative 8 equals v as our final answer. Number 11. So number 11, this one you do have to distribute, and the reason why is you can't divide negative 6 into both of these very nicely or very pretty. So it's going to be better just so you go ahead, use your arrows if you'd like. We're distributing, so negative 6 times negative 8 is positive 48. 22 plus 7n. And now we have our very first switcheroo that I really, really enjoy. So the switcheroo that I really enjoy is when you move all the n's to the left, all the numbers to the right. So this 7n and this 48 are going to switch spots. So 7n goes to 48, 48 goes to 7n. We got negative 6n minus 7n is equal to 22 minus the 48. Continuing on, we have negative 13n is equal to negative 26. Again, just adding like terms, negative 6 minus 7 is negative 13. 22 minus 48 is that negative 26. And now we're dividing both sides by negative 13. By negative 13, you get n is equal to 2. Continuing on over here to the right-hand side, we have negative 22 plus 8x is equal to negative 7 times 6 is negative 42. Negative 7 times positive 4x is going to be positive 28x. So again, we just did our little distributive property yet again. And yet again, a switcheroo. So this negative 22 is going to switch spots with this 28x. So it's going to be a negative 28x. If it was positive, it turns negative. Plus 8x is equal to negative 42. Negative 22 becomes positive 22 on the other side when we switch them up. And then you get negative 20x is equal to negative 20. And now we're going to divide both sides by negative 20. The x is equal to 1. Easy enough. Let's continue on. So we have number 13 over here. We have the negative 4 is going to be distributed to become negative 4n minus 16 plus 1 is equal to negative 14. Negative 2 distributes to become negative 4n minus 1. Again, all I did was my arrows going across, arrows going out. We have negative 4n minus 15 is equal to, what I did there was, by the way, is I had negative 16 and 1, and I combined them because they're like terms. Likewise, there are more like terms over here. We have the negative 4n and then the minus 15, and we have our very first special case. This is, again, what is called a trivial solution. Negative 4n minus 15 is, of course, equal to negative 4n minus 15. Anytime you have that trivial solution, it's going to be an answer of all real numbers, which I like writing as that big R or negative infinity to infinity. We're technically allowed to write ARN or just write out the words all real numbers, but I prefer one of those two answers there. Let's look at number 14. So problem number 14 here. On the left-hand side, we're adding like terms. Negative 4k minus k is negative 5k. So these two kind of come together. And then the 6 gets distributed to both, and we get 42k minus 42. And then over here, same idea, the 7 is getting distributed. So plus 42 plus 21k. Something cool happens in this question that I really like talking about. In this case, the negative 42 and the positive 42 completely cancel out, so we don't even need them anymore. We can add these guys as like terms. We have negative 5k is equal to 63k. This is a very common spot of confusion. There are two different ways to approach this one. At this point in time, you might be able to remember that there's only one number that you can multiply it by -5, and you can multiply the same exact number by 63, and the result's the same, and that is an answer of k is equal to 0. You might be able to just notice, oh yeah, it's got to be 0. That's the only number that multiplies for both of them right away. If that doesn't work for you, the other thing to do is just remember you can add 5k to both sides. You get 0 is equal to 68k, and then divide both sides by 68. Either way, you get k equal to 0. Number 15, same thing we've been doing. We got some distributive property. This one actually looks nice and simple. Maybe I made it easier right here at this part of the question. Not even going to explain this one because we just have distributive property, and then we have a switcheroo. We have more adding like terms. And that's it. That one was an easy one. Easy button question. Nice. Number 16. Now on this one, we're going to go ahead and distribute again. -64x plus 8 is equal to 8 minus 32x. In this case, again, doing that switcheroo. When you do that switcheroo, you get -64x plus 32 x equals 8 minus 8. We have another equaling 0 situation, so x is equal to 0. Very, very cool. I like those questions. And then now, the big boys. The fractions. The fractions. So, for this question, you need to use your calculator to find the LCM. I want to remind people how to do that really quick. So to do that on your calculator is what we're doing. So to do this on your calculator, ignore all that stuff. That is some calculus work. We don't need it right now. So on your calculator, what you're going to do any single time you have a question with a bunch of fractions, you need to find the LCM of all of these numbers. You're going to start by hitting math, scrolling to the right once to num. Number 8 is LCM. I actually like just tapping the number 8 on the calculator. Boom, I tap 8 on the calculator, and that's going to give me that LCM. By the way, if you're at home, you can do this using Wolfram Alpha. Just to let you, I'll show that in just a second. And Wolfram Alpha is actually faster if you are at home. I'm going to go 5, 4. The calculator can only handle 2 at a time. So we're going to go through this whole process, and then I'm going to show you how to do it on Wolfram Alpha as well, because it's worth seeing. So we have that 20 there. After you have the LCM of 5, 4 and get 20, what you got to do is you got to start typing in more things. So we have math, scroll to the right once, number 8, get the LCM again. And now we're going to put 20, comma. All we've done is we've taken the previous answer, we wrote it right there. And now we're going on to the next number, comma 80. So it turns out 80 is the least common multiple of those guys. If you're a smarty pants, you don't even need to do this next one that I'm about to hit, but I'm about to do 80, comma 2. And of course it's going to be 80 because we know that 2 goes into 80. So of course that is going to be the case. We could have said the same thing with 20 and 80. After that, the very last one you could do, another cute trick with the calculator is you can scroll up to highlight. So I'm going to use the up arrow key to highlight the LCM. And I can hit enter, and that's going to copy it. Because instead of a 2, I need this to be a 3 for that last one. Again, we are doing the LCM with every single one of these, and we finally figured out that the LCM for this question is 240. However, I just said that you can figure this out at home even without a calculator if you use Wolfram Alpha. There is a Wolfram Alpha app on the App Store. There's also Wolfram Alpha on websites you can just visit using Safari. So I'm going to bring this up over here. Here is my internet thing. I'm bringing this up. Oh, you guys can't even see it, can you? What a bummer. I'm going to fix that really quick. How do I fix it easily? Just give me a moment. All right, I fixed it. Here it is. I'm on Chrome. We got to open up, and we're going to a place called Wolfram Alpha. So we're going Wolfram Alpha is where we're going. So Wolfram Alpha is what we're looking up. This is the website that we want. So we're looking at Wolfram Alpha here. And for Wolfram Alpha, you just want to type in literally the same thing, LCM. The deal is the Wolfram Alpha will take as many inputs as you want, unlike your calculator. So the problem itself needed you to do 5, 4, and an 80, and a 2 and a 3. You type in all those together and it will spit out that correct answer of 240 that we had already found earlier. So there is that. Transition back. Okay, here we go. Continuing on. This one right here. So we are doing the LCM. Once you've found the LCM, you need to multiply every single term in the problem by that LCM. So we are doing negative 16 over 5n, and then times 240 plus 7 over 4n times 240 equals 129 over 80 times 240 minus 7 over 2n times 240 plus 4 over 3n times 240. Holy moly, so much work. Yet again, we are going to use our calculator to do the multiplication. We are going to do the negative 16 divided by 5 times 240. By the way, that will give you some big number, negative 768. You could have also used alpha y equals enter to get that fraction going, negative 16 over 5 multiplied by 240. Boom, you get negative 68. So use fraction button or not, doesn't matter. Either way, you get negative 768. We're going to do this for every single one of these questions. Don't forget the n, by the way. It's negative 768n plus. And now we're going to do 7 divided by 4 times that 240. We get 420n. After that, we are again multiplying through. We have 129 divided by 80 times 240. That's going to be 387. No n on that one this time. And then 7 over 2n times 240. So 7 divided by 2 times 240. Yeah, 840. This one was a minus, so 840n. And the last one's 4 over 3 times 240. And that one's going to be 320. Then we want to move everything over to the left that has an n. Anything that doesn't have an n off to the right. So a lot of copying, negative 68, then 768n plus 420n plus 840n. I'm copying that, minus 320n equals 387. Use your calculator to add all of those up. And I don't know what I just did, negative 768. I'm literally just typing all these in, negative 768 plus 420, and then it's plus 840 and minus 320. You get 172 equals 387. And finally, we can divide both sides by that 172, and we're finally done. 387 divided by 172 in the calculator will give you a 2.25. In fraction form. You can always convert your decimals into a fraction by hitting math and then enter twice. It looks like 9 over 4 is that other answer. Beautiful. Took all of that page of work, but we got to the correct answer. Feels good, man. We love it. This one over here, if you are a smarty pants, you're going to be able to figure out what the answer is just by glancing at it. So you might want to pause the video, see if you can just look at it and be like, oh, yeah, I know what the answer is. If you couldn't figure it out, job is to find the LCM. The LCM in the calculator one more time in case you forgot the steps. What we're doing is we hit math, we scroll to the right, we scroll down to number 8, LCM. We find LCM, you need all the denominators. In this case, we just need 3, 2 because there's only 2 of them, you get 6. You're going to take that 6 and you're going to multiply every single term by 6. We get 1 over 3 times 6 plus n times 6 plus 1/2 times 6 equals n times 6 plus 1/3 times 6. We use our calculator to multiply. I'm not going to show it again, but we're doing 1 over 6. 1 over 3 times 6 is 2, plus 6n plus 3 is equal to 6n plus 2. Continuing on, all the letters to the left, 6n minus 6n is equal to 2 minus 2 minus 3. We move the 2 and the 3 to the right. They became negative. You get 0 is equal to, what is that, negative 3? And this is, again, a trivially not true. The answer is the empty set, which you can write as that, or you can write NS for no solution, or the cute little curly bracket, double curly bracket there that has a meaning, no solution, but let's use that one. This is the shortest one right there. By the way, I said if you were smarty pants, you could have figured it out. The reason why is you have 1 over 3 plus n here, n plus 1 over 3 here, and an extra 1/2 that's clearly going to make the two sides not the same. So you could have known there's no solution immediately if you had been paying attention. Number 19, again, you need to find that LCM. I am not showing the LCM. I've showed it twice already, once on Wolfram Alpha, twice on the calculator. The LCM for this particular problem is 12. We are multiplying by 12. Another thing is you don't actually have to write this times 240 step, the times 12 step. If you're willing just to actually type it into your calculator, 5 divided by 4 times 12, boom, it'll give you that 15. You can do this for every single one of these. You get 15, by the way, LCM is 12. Get 15n. Again, I'm multiplying by 12. Maybe you just want to put like a times 12 up here for you so you remind yourself, you know? Just to be maximum laziness. Either way, you'll get 4 for that one, you'll get 13 for that one, and you'll get 6n for that one. Switcheroo time, 15n minus 6n is equal to 13 minus 4. We get 9n is equal to 9. Divide both sides by 9, and n is equal to 1. Only one question left. Woo! Number 20, here we go. So 415 divided by 12 is equal to, first step is to do distributive property with fractions. A little bit obnoxious, but still doable. When you do this, I recommend the calculator fraction button. That is, again, alpha, y equals, enter. When you do it, and it looks like we're going to go ahead and get 5 over 2, and we are multiplying that by negative 7 over 2. So alpha y equals, enter again, negative 7 over 2. Boom, we get negative 35 over 4. By the way, if you wanted to try to do that in your head, all you have to do is multiply the top, 5 times 7, multiply the bottom, 2 times 2. Nice. And 5 over 2 plus the 5 divided by 2. Anything times 1 is itself. Find the LCM. LCM in this case is going to be 12. When you multiply every single thing by 12, you'll get 415 for this one. I gotta move the paper up a little bit. So we get, oops, that not into my face. So 415 is equal to, now we have negative 35 over 4 times 12. When you do that, you'll get negative 105n. Multiply this guy by 12, and you'll get plus 30. Subtract the 30 on both sides. We get 385 is equal to negative 105n. Divide both sides by 105 using that calculator. Get 385 divided by 105, and it will tell you that n is equal to 3.667, or 6 repeating, just like so. But remember, you can hit math, enter, enter for the fraction, and you'll get the better version of the answer, 11 over 3. That's it, guys. Have a wonderful rest of your day, and peace out.